3.4, we're going to talk about the slope of a line. And the slope of a line is, if I just drew a random line, it's how fast it's rising. So a steeper line would have a bigger slope because it's rising faster. And if I wanted to describe the slope, we actually use the French verb monter. So we use m. M is the notation, the standard notation for the slope. And the slope, we're going to tell people it's how much it's rising for how far it goes over. So it's the rise over the run. Now, on an xy plane, if I wanted to measure that rise, look, we're getting the distance from here to here, and that would be the change in the y-axis. So the rise is achieved by taking one y value, subtract another y value. And the run, that would be this difference right here. So that's achieved by getting the same x value, subtracting the corresponding x value. So here's what you have to do. The homework says simply to find the slope, and the first thing they do is give you 2 points. So find the slope of a line through, and they just give you 2 random points. -1, 2, and 2, 5. So all we have to do, and this is a definite memorize, absolutely know that formula. The slope formula will haunt you. You've got to have it down solid. The slope formula, we know we just take m, because that represents slope, and we're going to take y minus y. Now, when you see these little subscripts, they still are just talking about a y. It's not the same as having y squared or something like that. It's not a mathematical operation. It just means that this y value and this x value coordinate. They're the same point. And the same is true here. Since I called it y sub 1 and x sub 1, that x value and that y value coordinate. So you can think of it as this is x sub 1 and y sub 1, and this is x sub 2 and y sub 2. Or vice versa. You could switch those. It wouldn't even matter. And I'll show you that. So if I'm going to do it this way, I would take this y value, subtract this y value. So I have 5 subtract 2 on the top. Now my formula says take x subtract x on the bottom. And here is the key. If you use 5 first on the top, you have to use its corresponding x first on the bottom. So if I use 5 first, I have to use 2 first on the bottom. So I would have 2 subtract -1. So we know 5 subtract 2 is 3, and 2 subtract -1 is 2 plus 1. So it is also 3. Now let's just show you. Suppose I had done it the other way. Suppose I had called this x sub 2, y sub 2, and this x sub 1, y sub 1. So let's say that I went y subtract y, and I went 2 subtract 5. Once again, if I use 2 first on the bottom, on the top, I have to use -1 first on the bottom. So I would have -1 subtract 2. So let's see. I get 2 subtract 5 is -3, and 1 subtract 2 is also -3. And guess what? They both equal 1. And that will always happen. Whether it's a whole number like we got or a fraction, they'll always be equivalent. And just for your knowledge, you should all know that -2/5 is exactly the same as +2 over -5. Those are both -2/5. And in fact, quite frequently that negative is written right smack dab in the middle. So if you see it in the middle, it's like it's going on the 2 or the 5, not both, because that would make it positive. So those are all the same thing, just for your information. Alright, so that's how you find the slope of a line. Now, the next thing they talk about is an equation, and it looks like this. And you can see that m right there. Let's circle this. Let's box this. This is an important equation. You can see that m right there, and we know we said that m is the slope, and that's still the slope. It's the slope indeed. Let's go ahead and graph this line and see if we can figure out what that B stands for. Now right now you might know how to graph it by x and y, by slope and b, but if you don't, let's just plot it and see what happens. So if I put in my easiest x value I can think of, 0, so I put in 0 right here, I get 2 times 0 is 0, 0 plus 4 is 4. So I'm over 0 up 1, 2, 3, 4. Then let's put in 1. If I put in 1 right here, 2 times 1 is 2, 2 plus 4 is 6. And if you need to, write that out. Plug 1 in and write it out and see that you get 6. So over 1, up 1, 2, 3, 4, 5, 6. Alright, let's go in the negative direction. Let's go negative 1. So if I put in negative 1, now I get 2 times negative 1 is negative 2. Negative 2 plus 4 is positive 2. So if I go negative 1 on the x, I go positive 2 on the y. And there is my line. And the fact that all three of them are lined up is kind of an indicator that we're probably correct. And now let's look. I know that the slope is right there, and the slope is in front of the x. And look, from one point to another, I go up 2 over 1. And we know when we don't see anything, it's like a 1 is there. It's an invisible 1. So my rise is 2, and my run is 1. And that's what this does, doesn't it? From point to point, we go up 2 over 1, rise over run. Now, how does this 4 play into this equation? Do you see on our line anything significant about the number 4? Well, you might notice that this point right here on the y-axis is 1, 2, 3, 4. Well, guess what? It will always work out like that. If you get y isolated like this, whatever's in front of x will always turn out to be the slope, just like we saw right there. And whatever is right here, the constant being added in the equation, is the y-intercept. So that's a really important equation, really good for graphing. So if I ask you to graph something like this, let's say I just said graph 2x I'm making sure I didn't already do it, minus 4y equals 8. Well, I could use my xy intercepts like we did in 3.3, or I could use my slope and my y-intercept. So let's try that. To do that, I have to isolate y. I have to begin by getting y alone. So right here, I'm going to subtract 2x from both sides. So I have negative 4y. Now the 2x is gone. And over here, one has an x and one does not. So don't try to combine them. Just say one plus the other. Then, to get y alone, we need to divide by negative 4. And this is big. We divide every single term by negative 4. So right here, negative 4 divided by negative 4 is 1. So I just have y. And then let's reduce a little bit. I've got 2 over 4, which is the same as 1 over 2. And I have a negative over a negative, so it becomes positive. So I have positive 1/2, and I still have that x right there. And then I know 8 divided by negative 4 is negative 2. So this is how I like to graph. I think it's the simplest way. There we have our equation and by the way, this has a name, and its name is exactly what it is. It's slope intercept form of a line. So that's one great way to graph. So now on my graph, I know that I crossed the y-axis at negative 2. So that's my first point. That's a point on my line. Whatever you see right there is 0, negative 2, 0, whatever it is. Then my slope, I'm going to go up 1, rise, over the run, 2. And that's enough to draw your line, those 2 points. Alright, now to finish this section, they talk about the slopes a little bit more. And I'm going to draw 4 lines. I'm going to draw a line rising. I'm going to draw a line falling. And I'm going to draw a horizontal line and a vertical line. And let's talk about their slopes. So if I wanted to find this slope, I could just pick 2 points and I could get their rise and I could get their run, and it would be some number. But look, because it's rising, I know that it would be positive. They would both be positive numbers. So it has a positive slope. Now, if the line is falling, like you read left to right, so falling from left to right, now I know it has a negative slope. Now, this is a tricky one. If I were going to find the slope of this line, I can see that I would have different x values. So I would take like 5 subtract 2 and I would get an x value. But what would happen on the y-axis? I would have a rise, but every time, does it go up at all? I would have a run. I'm sorry. Let's see, we've got rise or run. I would have a run. So I would have a value on the bottom, so we could put a number there. Let's just call it, let's pretend that this is 3. But what would my rise be? Does it go up at all?